All right. I see. Good morning, everyone. So I want to start out by looking at a couple of the homeworks here. So I'm trying to obscure the name here. So here I have a typical solution for homework. What was it? 2.7. And so if you recall, the assignment was to make a color object, to call the brighter method on it, and then to print out the result of that. So step 1 was to make a color object, and with the colors 50, 100, 150. Part 2 was to call brighter, and 3 was to print the result. And I know it sounds so simple. What could go wrong? And so let's look at this particular solution. And so I hope I obscured the name. I don't know. But this is that's something I want to see a lot. So did the solution make a color object? Yes. Okay. So did it call the brighter method? He says confidently, yes. Yeah. Where? I see it. Where do you see the brighter method? How would you call the brighter method?
Would be a method in your color.
Yeah, so somewhere, so this thing here would have to have the form some object, a dot, and then brighter. Right, that would be a method call. And so, is it there? It is not, right? So, and so I don't really know why. So here, what the student did is he come up with another object called my brighter color, and that actually it was not quite fair because it wasn't really brighter, right? It was the same color as the original. So what I look for is the whole purpose of chapter 2 is to practice this. Here's an object, here's a method, call the object with that method, and so that somehow got lost in this particular solution. So how do you do it right? So let's look at the first line here again. So here the student made a color object. And it's legal, right? That is a color object, but it's probably not very useful to just do it in this way. What's wrong with the first line?
There's no reference to the object like this.
There's no, one doesn't remember that object in any way, so you need to store it in some variable. And so let's fix that up and put here
Doesn't he do it in the second line though? With
well,
the bright color?
yes, I know that. The trouble I have with that is the name of the variable,
Oh, okay.
right? Because it's kind of dishonest to call it my brighter color when it actually is. So now let's call brighter on it. So I guess I might as well just hijack this thing over here. and call my color dot brighter. Now, does that make my color brighter?
Sleeping.
It doesn't, right? So, no, stop sleeping. Oh, no, I don't want to. Gosh, no, I don't want to lose all of this. Okay. So by itself, it does not make the color brighter, and I'll code that up in just a minute so that you see it. But I don't want to lose my writing here. So how do I? What does brighter do? It makes a brighter color, and then what does it do with that?
It just stores it somewhere.
It does not. It returns it as its answer. We had this thing in the last lecture. I said it's if I ask this fellow, and I think it was this fellow here, and say, make yourself brighter, and instead of becoming brighter, he gives me back a twin brother who's brighter. So what this method does is it creates a new object that is brighter. What should I do with that new object? I could print it out. The difficulty with that is then the printout won't look the right way. Yeah? Yes, I could do that. So I could say my color equals, and that would be perfectly fine. So the most important thing is I need to save it. So this method call gives me this precious result that I need to analyze later, and I need to hang on to it with my DLF. That means I need to store it in a variable. That's the whole point of having variables, to store stuff so you can use them later. And so this is a case in point. Now, there's two variables that I could use. I could store it back in my color, or, that's actually is where the my brighter color would make perfect sense, because that is now the brighter color. So an honest way of doing it here, we could just say my color dot brighter, and now I save that in another variable. And now I have my original color, it's called my color, my brighter color is the new one. And now I can kind of go on with the code that he already has, because this code is beautiful. It prints out red, and then the get red, and the green, and the get green, in exactly the format that I was asking for. So that's the good part about this, that instead of printing it in some random way, which some people have done, it followed exactly the prescription that I wanted to print it out just. So, so it's a very typical kind of thing that one sees at the beginning of the course, where people have these misconceptions, and it's kind of normal. I mean, you're learning a whole new language and a whole new way of doing things, and it's not at all obvious how these things should go. So let me quickly demonstrate what happens if you don't capture the value. Oh, by the way, it's always a good idea to start a new project. That way you don't have that dumping ground phenomenon that I've seen on so many of your desktops where you have like 19 different classes. So just start a new project and call it homework 4 or whatever. It's a cheap throw. So there's two ways I can do it. I can make a new class for this homework, or I can do what I demonstrated last time, and I'll do that one more time. So I'll say I want to use a library class, and that would be Java awg.color. And now which constructor do I want? I want the one with the 3 integers, 50, 100,
150. Here's my object, and now I'm going to call brighter. Here. Now here's my result. It's an object, and I have to now say I want to get it so that I can actually see it. And here it's called the color too, or whatever. So here's the original one, and here's the brighter one. Well, which of them is brighter? I mean, how do they differ? They both seem to be red. Why are they red?
Just the default.
Yeah, I mean, the BlueJ system has no idea what a color actually means. It has no idea that these things should represent color, so it always shows them in red. So let's look at what this actually is. So toString tells me this is 50, 100, 150. And on this one here, toString tells me it is 71, 142, and 214, whatever. So it's made all of the values a little bit brighter. And notice that I called brighter on this one here, and it didn't change it. Let me do it again. I'll call brighter one more time. And I'll get, I don't even want to look at the answer, but I'm going to call it toString again on it. So calling brighter on it never changes it. It just gets me a new answer. All right, so now with this inside, I'm ready to actually implement my program here. Or was it brighter demo? So this was the student S, the student assignment. Let me just run it real quick. And so you can see that it couldn't have been right. These are the same values, so it didn't make that color any brighter. And so now let's fix it in the way that I indicated. So here we would say color, my color, new color.
Wouldn't you make a new color for the My Brighter color though?
I'm sorry?
Wouldn't you make a new color for the My Brighter color?
So your question is, should I construct a new one?
Yeah.
And so that was a very good question. So his question is, why am I not constructing another one for this? And so the answer is, I'm not constructing it, but I bet you the brighter method does.
It's
So
constructing it based on your
That's right.
My
And
color.
it is doing the construction work for me.
Okay.
So when do you construct? You construct something when with the absolute inputs of your computation, the one that no other method can help you yet. But it's very common for methods to do some internal construction, and then they give you the object that they constructed. So brighter must do some kind of job, right? It must be reading these colors. It must make them brighter by some percentage. I don't actually know what that percentage is. It has some scheme to make them brighter. And then it makes a new color. And then finally, it hands me that color on a silver platter and say, here, sir, is your new color. That's what this method does. I then capture what was on the silver platter and put it into this variable, and then I can use it later. So all of that stuff goes on in brighter, and so it's important to understand how we can make these methods do our bidding. What protocol do we need to do to kick them to get them going? How do we process the answer? All right, so now let's just run this real quick. And now we get these different values. Now if I go back to the original for just a second. This was the original solution. And now, when you run this, the skill that I want you to develop is that you look at something like this. If this happens to you, if this happens to you, that I want you to look at these numbers
And what should you say to yourself when you see these numbers?
This is wrong.
Exactly. That is exactly true. So step one is, yeah, it's got to be wrong. And it's for people who just start out in this game, this is not always the most natural thing to you, because the most natural thing for a lot of students when they first look at these numbers is they look at these numbers and they say, oh, there are 3 numbers. You'd be surprised. And so and it's not the natural thing necessarily to look at the numbers. You've got to look at the numbers. And you've got to try by hook or crook to somehow make sense of these numbers. Are they going in the right direction? Are they totally wrong? And if they're wrong, you start thinking about it, and you might have no clue how to fix it. And then what's the second step? Well, let's say you can't. The second step is ask. It really is. And so a perfectly reasonable thing at this point would be to copy and paste that code, put it on Desire to Learn, and say, this doesn't seem to be right to me. It does not print any different numbers. It didn't make it brighter. What gives? And so when we look at just what people have done on Desire to Learn, there were a whole bunch of questions like that. So find my favorite one. Here, this one. No, that was not my favorite. Gosh. Oh no, I hope I can find it. This one. All right, so this fellow here says, here's my code. And let's see if I can make this any bigger. A little bit. And so he got an error message, and the error message was cannot find symbol, method next int. And so what's wrong with it?
Random.
Yeah. So, but the first person who submitted a suggestion did exactly what I was about to type. He said, "Oh, you must not have imported Java util.random." And then the person came back and said, "Well, but I did," and it didn't show up here, which is what confused me. And then I tried it again with the Java util.random in place. And then I got a slightly different error message, but I still got an error message. And so the reason for this was, okay, so again, what was the reason?
The class name.
The class name is random, so what's wrong with the class name random? Let me try my magic here.
All this technology.
I don't know why it keeps dying. My feeling is if I was making a product like that, I wouldn't call it a smartphone. All right, I've defeated it. So generally, there's nothing wrong with calling a class random, except this one here shouldn't have been called random. Why?
Because random is already one of
Because we're also importing random. So we have two randoms. And I must say, I looked at this last night, I didn't see it. I looked at it again this morning, and I said, duh. And these things happen all the time, that there's some pesky little thing that is so far removed from what you were thinking. You know, this student here was doing a good job. He was trying to think about, you know, he's adding one to it, so he was trying to do some real work. And this was a complete distraction. It was not something that was on anyone's mind. It's such a minor detail. But this happens all the time, that one of these little pesky things just blows you out of the water. And that's why I'm doing this submission in stages, that you're supposed to do a draft first and then the final version. Because it just sometimes takes a day or so to get rid of some silly little issue like that. And if it happens in the draft, no big deal. Then you have time to ask the question. And then someone has time to come up with a useful answer. Maybe you, maybe someone else. And yes, people were trying to help me, which I really do appreciate. So you just got to have that work habit that you try something out, and when you get stuck, just ask a question. And someone might say, there were a whole bunch of other questions that were asked when someone gave useful comments, or someone said, duh, I figured it out later. I'm not going to show this here, but there was at least a couple where people asked a question, and then later they withdrew the question because they figured it out. That's fine. Oftentimes, I find myself, maybe once a week, I put a question up that I'm about to hit the enter button, and then I read it through one more time to check for typos, and then the answer comes to me. And hey, whatever works.
So it's really important that you ask and answer questions. And just to belabor this even more, this semester I'm supervising a couple of rookie instructors for 46A and 46B. And so one of them is an engineer at some startup. He does Android programming. And he's for the first time teaching a 46B course. And so I looked at his discussion board, and it was empty. And I said, why are there no questions? Why don't your students ask any questions? And he said, well, he didn't encourage them to use the discussion board for questions. And I asked him, well, in your job, how many questions did you put on the Android forum? Oh, several a week. So this guy, on his day job, uses the Android forum all the time to have his questions answered. And it's just the way things are nowadays. You can't get your work done if you don't ask questions. I asked him, could you get your work done if the Android discussion board closed tomorrow? He said he'd be out of a job. He could not function without that collective expertise of everyone in the world who are helping each other. So it is a really important skill for you to learn, even if you don't like it. Even if you have to come out of your shell and ask a question, you feel stupid or you feel disorganized or whatever. You've got to do it. And so I really insist that I'm going to drive you relentlessly towards this discussion thing, because it is not just because it makes my life easier, but also because it is a part of the job these days. All right, back to our regular scheduled program here. There are a few things that I wanted to go over with before we get into a hopefully quick lab. The first thing is this test program business. So as we get more systematic about what we're doing with objects and with classes, we want to figure out how we test them. And so here's a little test program that you've seen in the book, where we're making a rectangle object, we're translating it, and then we're printing out where the rectangle has ended up. So we're printing the x coordinate, we're printing the label x and then the get x, and then afterwards, and that's the important part here, we're printing out what we think the answer should have been. So in this particular case, x started at 5, we're translating by 15, and so therefore we're expecting the answer 20. And then when you run this program, it's going to say x 20, expected 20. And when you look at it, you see right away the world is good. Now, I've known students who said, why don't I just first run it, and then I'll watch what the value of x is, and then I fill it in and run it again.
And of course you can do that. And then the world will appear to be good, but it's not a good idea. The reason I want you to put this in is it forces you to think what this thing should actually do. So let me go back to the brighter demo for a second. Let me fix it up. It's amazing how fast you can type, huh? So this one here does not have this shape. I didn't put it in expected here. So let me say I do that. System dot out dot println. Okay, what do I expect? So I'm starting with 50, 100, 150. I'm making it brighter. What do I expect for the red value? Yes, and that would actually be a good thing to do. I could say greater than 50. And unfortunately, I don't understand the logic of brighter any better. What I could do is I could look up into the specification of brighter and see what it actually does. And then I might be able to print a better message, an actual number. But as it is, I could at least print what my expectation is. And that is a good idea because it forces you to think about, well, what do you expect? And you'll be amazed how much of a difference that makes. The other reason is that eventually we want to have it so that the grader can just automatically do the testing. And it greatly helps when you have a standardized output format. So the output format that we will use in the class for just about anything is it's always going to be some label with a colon followed by a number and then expected and then what you expect. Most of the time it's going to be an actual number. Sometimes it might be some text message. Alright, so that was one of the things that I wanted to drill down on. And that really is the only moral of this whole section on testing. Say, figure out what you expect. And then finally, I need to talk about this kind of technical material about object references. And so you need to have the right mental image about how objects are stored. So when I have a variable box, and box holds a rectangle, then actually box does not hold the object. Box holds what's called a reference to the object. The object is stored elsewhere. And you can have a second variable here that I call box2. And when you make an assignment, box equals box2, that means that the reference gets copied. The reference is kind of the house number of this object. It tells the system how to find that object. So the object lives somewhere in object land, and these references tell the system how to find the object. The important part to realize is that box and box2 reference the same object. Every time that you make what seems to be a copy of the object by saying box2 equals box, you're not making a copy of the object, you're making a copy of its address, of where it is. Now, you can observe that. Suppose now I call box2.translate. So what translate does, let's say it was originally 5, 10, 20, 30. Oh, actually, I know what it is. Originally it was 0, 0, 0, 0. That's what the default constructor does. So now I call translate. That changes this thing to 15 and that thing to 25. And if you look carefully, I called it through box2. So box2.translate. Now what happens when I print box.getX?
Does it return the value of x?
It'll return the value of x. And my question is, does it return 0 or does it return 25? Or 15 rather? Because if we follow through box, the box was constructed as this rectangle, which is the same as the default constructor gives me 4 zeros. So I never translated box, right? I left box alone. Now I'm asking, what does it get x? Is it 0? Or is it 15? So intuitively you would think it's got to be 0, right? But that's not what it is, and here's why. So one follows the pointer to box, and it leads us to this blob. This is the exact same blob, the exact same object that box 2 also refers to. They both refer to the same thing. Now box 2 was munged by this call here, and box will observe the same thing. So box will see the change. Most of the time, we don't really have to worry about this because we don't often make copies of the object in this way. Sometimes we actually like this behavior. We can give this reference to some method and say, hey, do with this object what you want, and then when the method returns, the object has been transformed in a way that we like. But it is just something we have to understand. So when you have a variable, it does not hold the object, it holds the reference to the object. You can have two variables pointing to the same object. So, and so one analogy that might help you is, you and you could have the same friend. You beat up your friend, next morning you see that the friend has a blue eye. So it's the same kind of thing that you have you're pointing to that object, you have a reference to it. All right, we'll see that a few times, and I'll remind you of that fact, and it'll become clearer over time. Now let's move on to quickly finishing lab 2. Now we did parts 1 to 10. Many of you jumped ahead a little bit, so go ahead and do 11 to 20 and turn it in as far as you can get this morning. So I think it's open till 11:30 or so. 11:59. Yeah, that's fine. All right, get going with it. Yeah.